Phoenix Inspection Systems is a manufacturer of ultrasonic non-destructive testing equipment, mainly for the energy sector. We produce ultrasonic transducers and manipulators and scanners for the inspection of nuclear power plant through to oil pipelines and then down to general fabrication applications.
EPSRC KTA funding provides a mechanism, and it's quite a simple mechanism for university academics to work with industry. And the benefit to the university is that firstly we get to see our research transferred into industry and real applications out of it. But it also allows us to better understand some of the problems that industry have.
The Acoustic Ranger that we've worked with the University of Manchester on, that is a product that we've, since the inception of the company, we've taken through several stages. We're now up to generation number 5, and this work with the university is now generation number 6.
The technique that we've developed injects an acoustic pulse into the pipe, and the acoustic signal will then propagate along the length of the pipe. Wherever there's a defect in the pipe, some of the acoustic signal gets reflected, so we can start to identify where in the pipe defects are located. The main challenge that we had with this project from the start was we're used to detecting very large defects in pipes, and the type of defects that they need to be able to detect in small heat exchanger tubing is the very subtle changes in the wall of the tube.
The university have now taken the product to what we call the alpha prototype. So we've solved the problem technically in the laboratory. We've now done some small trials in the field, and we have a working instrument. So now the follow-on situation is for us to take that through to the beta prototype prior to launching the product.
What we intend to do is to continue to work with Phoenix to improve the device, so they will have a beta prototype which will be released later in the year, and we'll help support that. But in the longer term, we're trying to now work with the gas distribution network companies to try to develop equipment that can target their industry, so detecting blockages and leaks on the domestic gas distribution networks. And again, we'll be working with Phoenix as well as other companies to provide that solution.
Generation 6 will open new markets for us. We, with our existing instrument, tend to concentrate on larger diameter tubes and pipes covering longer ranges. With Generation 6, we're going to be looking at smaller diameter tubes, smaller ranges, but much higher sensitivity.
My PhD was very academic. In this project, it's been very much commercially structured, so Carl's always been telling us what things he wants doing, and I've had quite strict time frames to get things done, and it's improved my focus quite a lot on solving the task and actually solving the real problem rather than solving the problem that I want to solve.
I would encourage companies to get involved in universities if they want to develop new products. For us, this has been a very cost-effective and a very timely solution. So, normally people might think that working with the university, it's going to take a long time to produce the product. But in fact, this was probably a much shorter route to market.
The main benefit of this project for me is that it's being used. Phoenix are taking it up and it's going into industry. I mean, in academia you can work on a lot of really interesting stuff but never see it realised. And the fact that this is being immediately realised and going to be used and going to be useful to someone straight away, that's a big benefit for me.
Obviously, we've obtained the prototype that we wanted, but also I think we've gained a working relationship with the university, so we're keen now to do other projects with them as well.